Hey everybody, it's Mr. Geiselman here to talk to you a little bit about balancing chemical equations today. So we're going to be taking the coefficients and subscripts and we're going to be attaching them to chemical equations to create balanced chemical equations that match up with the law of conservation. So when you're done with this ed puzzle today, you're going to have to get onto PhET.com and complete the PhET lab. You're going to need to have 5 stars on all 3 levels, and I'll go through what that screen should look like, and that's the picture you're going to be submitting onto Google Classroom today for credit. So here we go. When we look at balancing equations, we have to use the law of conservation. That means we know that the products of a chemical reaction must end up equaling the reactants of the chemical reaction. What that really means is that we can't end up with more stuff at the end than what we started with, or we can't have more stuff at the beginning of a chemical equation and less at the end. We have to have equal amounts of atoms of each type on each side. A really simple example would be making a s'more. In a s'more, you start with 2 cracker squares by themselves. You start with 1 marshmallow by itself and 3 chocolate squares. You go through the chemical reaction of putting those ingredients together to make a s'more. You make 1 s'more at the end by using 3 chocolate squares, 1 marshmallow, and 2 cracker squares. Well, if we wrote that as a chemical equation, we have 2 cracker squares, 1 marshmallow, and 3 chocolate squares. That forms together 2 chocolate squares. So the subscript 2 here talks about that one. Okay, so 2 chocolate squares, 1 marshmallow, doesn't have a subscript because it is 1, and 3 chocolate squares. So the coefficient in front means how many of all of this compound together we have. The subscripts mean those individual pieces. So 2 cracker squares. There's 1 marshmallow, so there is no subscript there. And 3 chocolate squares, because 3 chocolate squares go into 1 s'more. That's a really simple example, and we're going to look at another simple example here in a second. This next example is magnesium and oxygen to form magnesium oxide. I'm going to go up to the board and write on the board, and this is just one method of doing this, but we'll go through another here in our PhET lab example. So when we look at magnesium plus oxygen to make magnesium oxide, oxygen is found as a diatomic atom in nature, meaning that an oxygen will bond with another oxygen. It won't be just its single self on its own. So that's why we see it as O2. And now we need to do some balancing. When we do this, one way of balancing equations or determining how to balance equations starts by creating a T-chart of the products and the reactants. So we have the reactants on one side and the products on the other. And what we're going to do is we're going to list the different reactants, the things that are on the left side of the arrow, and how many of them are there. And then we're going to match them up with what's on the right side, the products. So when we do this, we see that we have 1 magnesium, and we have 2 oxygen atoms. And now we'll go to the other side of the arrow. We'll go to the products, or what's left after the reaction, and determine how many are there. Now we see that there is 1 magnesium and 1 oxygen. This is where we need to do a little bit of balancing because we want to be able to make the oxygens balance, and that's what's off right now. So we have 2 oxygens on one side, 1 on the other. The first thing we should do, we should make sure that both sides have 2 oxygens. And the way that you would do that, if we start again, I'm going to put a 2 in front as a coefficient. All right, that now gets rid of that 1 oxygen and makes it 2 oxygen. And now these 2 balance. When they balance, that's great. We can get rid of them. We don't have to worry about them. But this 2 also goes not only to the oxygen, but to the magnesium. So now instead of having 1 magnesium on the right side, we have 2. So this causes a little bit of a problem, but it's a pretty easy problem to solve. What we're going to do is we're going to have to make sure that the magnesium balances on the left side as well. when we do that? Very simply, we can put a coefficient of 2 in front of the magnesium. This does nothing to the oxygen that's right there because they're separate at this point. So if we put a 2 in front of there, we now have 2 magnesium on the the reactant side and the product side. They now equal out. And our new balanced chemical equation is 2 magnesium plus O2 gives us 2 magnesium oxide, MgO. And that is a balanced equation. We're going to take another look at a PhET lab example, and this is actually going to be your homework, is the PhET lab. So if we look at the PhET lab example, they do it a little bit differently. So in the PhET lab example, we're going to go to game, and then we're going to balance the equations on either side. The PhET lab does something that's kind of nice. It puts actual atoms out there. So if I click on this, and I see that 1 N2 plus 1 O2 gives us 2 oxygen and 2 nitrogen on this side. Well, I need to know I need to have 2 nitrogen and 2 oxygen on this side. So what do? I'm going to try and balance that. So I have 2 nitrogens on each side, 2 nitrogens there. Good. I have 2 oxygens on each side, 2 oxygens there. Everything looks balanced by having 2 NO gives us or yields 1 N2 plus 1 O2. When we check, that is balanced, okay? So I got a score of +2. All right. My next one, I have P4 or phosphorus 4 plus F2 is going to yield PF3. Ooh, this one's a little bit tougher. Well, let's add 1 to begin. Oh, if I have 1 P4, I know I have to have at least 1. I'm going to need 4 phosphorus over here as well. So since there's only 1 phosphorus in this molecule, I need to add 4 of them to make that 1. And that leaves me with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fluorines. Well, 12 is equal to F2 times 6. That would give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fluorines on this side. So my phosphorus, 1, 2, 3, 4 equals the 1, 2, 3, 4 over here. And my fluorines equal the 12 on this side and the 12 on this side. Let's check. It's balanced. All right. And now if I go back to the game page, which I might be underneath here, that will show me that I have 2 so far, 2 stars out of 5. All right. Your job is to get 5 stars out of 5 at each level. So if I go, let's see if I can get back to that. It doesn't look like it. I want to get 5 stars on each level. Now, each level gets a little bit harder, but you can still use that same method of counting atoms on each side. So, for example, I have 1 nitrogen on this side. I have 1 nitrogen on this side. That works. I have 2 hydrogen on this side. 1, 2, 2 hydrogen, or excuse me, 2 oxygen on each side. 2 oxygen over here. That works. But I have 1, 2 hydrogens, 1, 2, 3 hydrogens on this side. I'm going to have to do some changes. Well, if I do 6 hydrogens, I can get 6 hydrogens over here. That gives me 1, 2, 3, 4 oxygens and only 2 over here, but it also gives me 2 nitrogens. So if I go 1, 2 nitrogens, 1, 2 nitrogens, those equal out. I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 hydrogens. But now my 1, 2, 3, 4, 5 oxygens are off. Well, now I have 6 oxygens on this side. How am I going to figure this out? So you're going to have to go back and forth balancing this until we have a correct equation. Now, if I check and I'm wrong, it will show me why. All right. I see that, oh, I have 5 oxygens. That doesn't tell me that, and I have 6 over here. My job is to correct that, and I can try again. I can start over, and I can completely start over with the whole thing with that level. This will hit refresh, and this will clear it. You need to take a screenshot of this page with all 3 levels having 5 stars, meaning you got 15 of them correct. Have a fantastic day, everybody, and I'll talk to you later.